Today, we're going to review the Elegoo Neptune 2. I didn't even know that Elegoo had made a Neptune 1, I just knew them for their resin printers, but somehow, with the Neptune 2, they managed to make a decent competitor to the ever-popular Ender-3 series, and especially the Ender-3 V2, that is actually better in a lot of ways. But there is a tiny problem. Elegoo aren't letting you buy the Neptune 2, which is puzzling to say the least. But first, a bit of disclosure. Elegoo sent me this printer free of charge. I do not have to send it back, but they did not pay for the review or have any say in it. I have had Elegoo as a sponsor on the channel in the past, and that's because I think they make worthwhile printers overall. This video does have a sponsor though, and that is Extruder and their new matte XPTG. I'll be using the XPTG and Extruder's PLAs throughout this review. So, what is the Neptune 2? Well, it's an Ender-3 basically. Because the Ender-3 is an open source design, it has become pretty much the standard printer base design by now. And while that recipe works, it has become somewhat rigid and does leave quite a few details on the table that other manufacturers are starting to pick up. The Neptune 2 still has the standard 220 by 220 by 250mm build volume, the tool head, the extruder, the hot end and all that. That's all practically identical to the Ender-3. But where it really starts to differentiate itself is in the details, like not using a glass bed, trying a different and, actually better in some ways firmer, and providing a slightly better slicer experience that all means that you can use the Neptune 2 with no mods, no software tuning for the most part, and get super impressive results right out of the box. You get silent dynamic drivers, a filament sensor, no power failure detection, or any of the other, more advanced software features. So let me start out by running you through my favorite details of the Neptune 2. First, the flex bed. So when I unboxed this printer, first off, honestly, I kind of laughed this one off because it's obviously a super low-cost alternative to spring steel beds that clamp down magnetically. You just use binder clips on 4 corners, so removing it and reinstalling it is kind of a pain. But this FR4 bed is actually a lot better than not having a flex bed at all. If the alternative, is a glass bed, then you might need to chisel prints off when they stick too well. I will prefer this every single time just to have that option of removing parts in those few cases where they don't just pop off. Now, the BuildTak knockoff surface on here has extremely high adhesion. You can see that I tried to reduce it with some glue stick already, so you'll need to make use of that flex plate more often than on a lower adhesion surface like on the screen printed glass on the Ender-3 V2. But that also means that prints will stick down perfectly every single time. Not having that thick sheet of glass also means lower weight on the moving bed, which helps with printing crisp corners, and it also improves thermal transfer from the aluminum bed to the top of the print surface where you actually need that temperature. Then the electronics and the full color touchscreen. Now, this is not the world's best design and prettiest interface, and there are lots of things that I wish they would do differently, like having a preheat option without triggering the filament change cycle. But one of the really cool features is that, similar to the Prusa Mini, you get a print preview when you go to start your next print, and then a higher resolution one once it's printing. This is super useful once you've got your micro SD card filled up with G-code files and are trying to print, that one thing. The way this is implemented is actually, ridiculously simple. It's not a JPEG that's sitting on the card as you would think alongside the G-code file. It's not metadata. It's literally lines of G-code with ASCII color codes. I mean, it's not space efficient at all, but it works really well, and it's a simple system that could be implemented into other printers or other slicers. Speaking of slicers, this is the last point I want to make that Elegoo does better than Creality, and that's the software/slicer. Both use a skinned version of Ultimaker's Cura, and it still prompts you to update to the newer mainline version of Cura, which of course would break a couple of things. But the way that Elegoo adapted Cura is actually usable and has been my go-to slicer for the Neptune 2. The big difference to the Creality version is that you get to use all the profiles. So the different profiles for layer heights work, the different material profiles work without giving you warnings. That's super convenient. It looks like the profiles have been at least a bit tuned to the Elegoo Neptune 2 because the prints look excellent. The one thing that I found that was still just straight up wrong was that the material settings were set up super cold. Like printing PLA at 200 degrees and PTG at 215 degrees, PLA works, but doesn't give you, the absolutely strongest prints possible, while the preset for generic PTG is printing so cold that prints literally crack and delaminate while printing. So yeah, that's not great. So about that print quality, it's actually impressively good. Again, this is definitely a side effect of the relatively cold print temperature, but comparing the prints from the Neptune 2 with the ones from the Ender-3 V2, the Neptune 2 easily beats the Creality machine. Not by a lot, because the Ender-3 V2 already prints just fine, but prints do look a bit nicer. For example, Clock Spring's Torture Toaster has all its overhang bits. Let me open this up one real quick. Clock Spring's Torture Toaster has all its overhang bits printing perfectly on the Neptune 2, while the same print, not the same G-code, shows quite a bit of curling on the steepest overhang setting on the Ender-3 V2. Also, the tolerance tests all came loose except for the 0.1 one perfectly on the Neptune. You can see those slide perfectly. Not so much on the Ender. These are all pretty stuck in there. The toast pop-up mechanism works perfectly on the Neptune. The one on the Ender already broke. I mean, I don't think you can print these better than this on any printer, really. The 3D Benchy printed totally fine on both. This is some old extruder PLA. It's been sitting out in the open forever. In fact, I don't think they even make this exact PLA anymore, but you can get the newer PLA NX2 in the same yellow color. Also, trying out the actually current PLA NX2 in the matte black everything color, this Medusozoa mushroom by Grim Greeble printed really nicely on both the Ender-3 V2 and the Neptune 2. It's a gorgeous model to start with. And then for some PTG prints with the Extruder X PTG in white and black, we do start seeing some differences. First of all, this two-way screw by G's printed at 50% scale. This is the one that failed on the Neptune 2 with stock settings. I reprinted it at 235 degrees on the hot end and the fan turned down to 30 to 50%. This time it printed just fine and looks great, but the nut doesn't actually mesh with the screw all that well. They're just too tight. But I actually prefer this over the version from the Ender-3 V2, which fits better, but is actually quite under extruded and is super weak. Also, this somehow printed at 0.1 millimeter layer height. I'm not sure how that happened. Must have been something with the slicer profiles getting shuffled around when changing materials. This one is a lot stronger. And lastly, to try out how well flat and even vertical surfaces come out, I printed the outer shell of Mikuláš Sousa's self-wadding planter design at 50% scale, and they're both doing an okay job. The surface has a bit more of that stepper motor pattern on the Neptune 2 and is a good bit stringer because, well, I had set it to print 25 degrees hotter than on the Ender-3 V2, which of course is amplified by the fact that, these are Bowden printers and the hot ends on these aren't exactly precise. The strings might also just be path optimization in the slicer. Either way, the Ender-3 V2 didn't finish the print in the XPTG at all because it was starting to curl up quite a bit because the bed wasn't sticking down well enough. So, like I said, this is a high adhesion bed, that's a low adhesion one. This sticks better, this is harder to remove. That is easier to remove, but you will have some issues with parts just coming up. I mean, I guess both the Ender-3 V2 and the Neptune 2 do need a bit of love on their slicer profiles, especially to print PTG. But overall, at least for PLA, what you get out of the box with the Neptune is really impressive. I also printed most of the parts for the fully printed speaker. And even flexibles were printing really well on the Neptune 2. Except for, the slicer not capping off the surrounds in a way that works, but that's a real edge case there. So, Tom, overall getting this over the Ender-3 V2 seems to be a no-brainer, right? After all, it's $100 cheaper too. Well, cautious yes. So, of course it has some minor flaws. The printer overall feels less well made than the Ender-3 V2, but still better than the original Ender-3. For example, yeah, that power supply shroud is just not fixed in place too solidly. It's not coming off, but it's not inspiring confidence either. The screen could be brighter, and it's also in a super awkward spot under the bed. So when you're printing large parts that have the bed coming all the way forward, or simply at the end of a print, you literally can't see or operate the touchscreen. And there are some issues with the electronics that are just unnecessary. So it's using a ZNP Robin Nano, which is based on an MKS board of the same name. It has room for expansion with, for example, a BL Touch header, and it is compatible with firmwares for the MKS board. By default, it's not running an open source firmware, but the one that comes stock from the factory at least has the more important thermal runaway protections in place. Side note on the topic of open source, Elegoo are actually sharing the drawings and designs for not just the electronics, but also for the mechanical design of the whole printer. However, it's not under an open source license, so technically you aren't really allowed to do anything with those designs except look at them, but it's a start. It's also missing the firmware source files. They're only including what looks like config files. But back to that ZNP Robin Nano board, I would like to see a few fuse in here because by default the only thing limiting current in case of a short or a worn-through cable is the power supply itself shutting down. But also, why Elegoo? Why are you still tinning your wire ends that go into screw blocks? What's going to happen here is that the tin, which is a very soft material, is going to flow out under the pressure from the screw, and after a year or two, that connection is going to be loose and an absolute fire hazard. And I doubt this board has a temperature sensor in the connector area to detect an overheating situation like that. So if you get this printer and plan on using it for longer than a couple of months, open up the bottom panel and cut back the wires until you get bare copper. Maybe put some crimps on it if you're an overachiever, but it's really not necessary with this type of screw block. Otherwise, the electrical is fine. There's a moderate amount of strain relief in place that maybe isn't going to hold up to printing for tens of thousands of hours, but you know, it's fine for what this printer is going to be used for. But who exactly is going to be using this printer when nobody can actually buy it? Because you can't. At the time of writing this review and filming it, the Neptune 2 specifically, as well as, for example, the Saturn, just aren't available for purchase, and it's been that way pretty much ever since those came out. I don't know, half a year ago. We've been seeing the same thing with the Mars, and the Mars Pro, and the Mars 2 Pro, where for weeks at a time, they just stop existing on the market and then like 10 or 20 units appear on Amazon, and 3 hours later, those are all sold out with no options to still order and wait for the next batch, and no indication for when more units might arrive. During that time, it literally looks like the entire product has been discontinued and you don't know if it's ever going to come back. Now, I don't know how many units of these Elegoo are actually making, but I'm baffled by the fact that this was an issue with the original Mars, and over 2 years later, it still is with the products Elegoo are releasing today. I've already shifted the unboxing of my Saturn back week after week because it's effectively vaporware. With this review though, this has been in the schedule for a while and I just wanted to get it done. And I mean, it's a shame that Elegoo are messing up with actually making sure you can buy their printers, because these are good products after all. None of the cheap sub $300 filament printers are really exceptional. They're all okay. And with all of them using mediocre parts somewhere, like the hot end extruder combo, it's little details here and there that differentiate them. So when there is the option of getting either an Ender-3 or the Neptune 2, I would probably go with the Neptune. But if the Neptune isn't available, the Enders are totally viable machines too. Like I said in my review of the Ender-3 V2, these printers are getting decent enough that I would personally be okay with using one as my main printer, and they are becoming more beginner friendly by providing a more complete package of usable hardware and software that doesn't require modding and tuning everything, but they still have ways to go until they can do everything out of the box without any tweaking. But that's where stuff can easily go wrong. Again, there's nothing wrong with buying a 3D printer as a hobby if you enjoy working on machines and learning about stuff, as long as you don't actually expect to use that 3D printer to 3D print stuff. And with a review, I can only share my take on what the manufacturer provides and not on the things that you can then turn them into. In either case, that's my take on the Neptune 2. It's a very decent printer if you can get your hands on one. Thanks again to Extruder for sponsoring this video. As always, I've got the links to all the materials I used in the video description below, as well as links for the Neptune and the Enders. If you enjoyed the video, give it a thumbs up, get subscribed, do all those things. And you could also consider checking out Patreon or YouTube memberships to support the channel. Thanks for watching, keep on making, and I will see you in the next one. Bye.